All right, so this is a video about Module 3, Lesson 6. We're going to talk about these things called quadratic functions today, and they're going to look familiar. The ax squared plus bx plus c, it's part of what we used back when we were talking about the quadratic formula. We were able to solve those when they were equal to 0. Not going to be equal to 0 anymore in all cases. We're just going to have a function notation statement like this. F of x equals ax squared plus bx plus c is going to be our standard form for these quadratic equations. Okay, and what we're going to do is we're going to look at more than just the intercepts for these things. We're going to look at the whole picture as for any x value. And what's going to happen with these is we're going to get graphs, and the graphs are going to be kind of U-shaped. They're going to have this general shape. We call this a parabola. Okay, it could open up like this. It could also open down like this instead. So our quadratic functions are going to have graphs in the shape of parabolas. Okay, it's very easy to tell which of these two graph shapes we have. We can just look at our a value here in the front, and if our a is positive, okay, then we know it opens up, and if our a is negative, then we know it opens down. So very quickly and easily you can tell which one of these two cases you're looking for. Next, there's going to be kind of a key point on each of these, like right down here on this one that opens up, and right up here on this one that opens down, kind of the bottom of the valley if we're opening up, and the top of the hill if we're opening down. Okay, those points are called the vertex of each of these respective parabolas. Okay, that's a vertex there. That's a vertex up there. Okay, and we really have to have this in order to get our graph. There's going to be some nice things that help us. A property called symmetry that's very helpful, but none of this is useful unless we have that center point of the graph, that vertex, in order to help us get started. Okay, and so for these quadratic functions in standard form, there's just a little equation that we can use to help us calculate that vertex. To find the x value of our vertex, we're just going to plug into the formula x equals minus b over 2a. And this looks like a new formula. It's really not totally new. If you think about the quadratic formula that we dealt with earlier in the module looks like this. Okay, all that this is, it's just the first part of the quadratic formula without the plus or minus and the radical part on there. Okay, so it's not something that you have to completely memorize new, right? Since we already know the quadratic formula, this is just the first part of the quadratic formula that helps us get the x value of our vertex. Now, the problem with this is the vertices are going to be points. And so we need an x and a y. This is the x value, right? So to get the y that goes with it, all we're going to do is we're going to take our minus b over 2, whatever we get there, and we're going to plug it back into the function and work that out, and that'll be our y value. Okay, so I think this will make a little more sense when we look at some examples and make it a little less mathy, but this is going to be our strategy for finding the vertex of these parabolas. Okay, so let's look at a quadratic function, and let's figure out some facts that are going to help us get a graph on this thing. So the first thing that jumps out at me about this is that my a value here in the front is a positive 1. There's nothing written there. So right off the bat, I know that this graph is going to open up, right? So I'm expecting a parabola of this shape, okay? Next, I can figure out where the center of my graph is. And again, for all of these, we really have to have that center in order to get off to a decent start. So we're going to use the formula x equals minus b over 2a in order to get started. That'll give us our x value, and we're going to get our a, b, and c just like we do for the quadratic formula. So my b is negative 8. I want the opposite of b on the top, so that's going to be a positive 8. Over 2 times a, which is 1. We'll work that out. And we'll get 4. And now we're not done, because this is just like half of our vertex. It's our x value. We need to get the y value that goes with that. And the way that we're going to do that is we're just going to take our x value, we're going to plug it back into our original equation, and we're going to get the y that goes with it. So we're going to calculate f of 4 here, plugging it in. Okay, working it out. So that's 16 minus 32 plus 15. 16 and 15 makes 31. 31 minus 32 is -1. And so there's the center of our graph. Our vertex is here at 4 and -1. Okay? Okay, so if I want to graph this, I'm going to set up my grid over here, and I'm just going to start by plotting 4, -1, that vertex value that we found. Okay, so that's going to be the center of our graph, and then we know that this is going to open up. Again, we talked about how our a value is positive here, so this is going to be a u that opens upward. We do need at least one more point, though, in order to graph this thing in MyMathLab. And so what we want to do here is we don't want to pick x values at random. What we want to do is we want to pick x values that are close to our vertex, because those are going to give us reasonable y values that go with it. Our vertex is at 4 and -1. So I'm just going to choose something that's near 4 to plug in. I'm going to pick 5. Again, there's no, you can pick whatever you want to plug in, but again, if you choose values that are close to our vertex, in general, you're going to get, you can give yourself the best chance to give yourself reasonable points to work with. So if I plug my 5 in, I get 25 minus 40 plus 15, that's 40 minus 40 is equal to 0. And so 5 and 0 will be a point on my graph. The nice thing about doing this in MyMathLab is if you're graphing this thing in MyMathLab, it's going to shape, you're going to choose your parabola tool when you're on there. And with these 2 points, if you give it, you have to give it the vertex first, and then a second point like this 5, 0, it's going to shape the rest of the parabola around there. Okay, there are some properties to this that we would use maybe a little more if we were going to do these by hand. We don't necessarily need them in MyMathLab, but there is a property called symmetry. Okay, if I draw like an imaginary vertical line up and down through this vertex, this parabola is going to look exactly the same to the left of that vertical line as it does to the right of this vertical line. This is a property called symmetry. Okay, it's basically a mirror image reflected over that vertical line. Okay, and what that tells me is that this point 5, 0 is 1 unit to the right of our vertex, right? And so 1 unit to the left of our vertex, we would be at 3. We're going to have exactly the same y value every single time because of the symmetry of this shape. So 3, 0 would be another point that would show up on our graph. Okay. Similarly, we could find the y-intercept for this graph pretty easily. We just have to kind of remember back to what the word y-intercept means to us. And y-intercept is the point where x is equal to 0. And so when we have an equation like this, if we want to plug 0 in for x, bye-bye to everything that has an x value in it. And so 15 is going to be our y value. Again, we got this by setting x equal to 0. And so 0 and 15 would be our y-intercept here. So if we want to find that, we're just going to plug 0 in for x, and all of the terms that have x's in them are just going to go away. So really, if you're in standard form, then your y-intercept is always going to be located at 0 and c for these quadratic equations. Okay, we will have a few application style problems for this module as well. One example from your homework says we're going to throw a baseball up from a ground with an initial velocity of 32 feet per second. It tells us that the speed of the baseball is given by the equation s equals negative 16 t squared plus 32t. Okay, I'm going to try to find the maximum height of this ball. And this is these parabolas are actually very practical things to think about the real world with, because it's exactly what happens if you throw a ball in the air. If you throw a ball in the air, it goes up for a while, reaches some kind of a peak, and then it starts to come back down, right? And this is a quadratic graph that we wind up with if there's no air resistance. And so this point up here is going to be our maximum height. I'm sorry, I think I said S was speed. S is actually the height of this at time t. Okay, so if we want to plug into this and find the maximum height, really what we're trying to do is we're trying to find the vertex of this parabola. Okay, so again, we've talked about this. We want to find the vertex of our parabola. We're going to start by finding the x value. And our x is going to be given by the equation minus b over 2a. So we plug into this. B is 32, so we want the opposite of b, so that's negative 32 over 2 times negative 16, since that's our a value. We'll work this out. Negative 32 over negative 32 is equal to 1. Okay, so our time at which this will occur is going to be 1 second, right? We didn't find the maximum height yet, though, right? Remember, the height is our y value. So we want to take this 1, we want to plug it in for t in our equation here. Whoops. Plug our 1 in for t, work it out. And we've got our y value. And so this is going to be our maximum height. Our maximum height is 16 feet for this particular problem. Okay, so we want to think about it, but we will certainly see some application problems, and they will involve throwing a ball in the air, because you get a quadratic equation when you throw a ball in the air. It's for the height with regards to time. Okay. So hopefully that's enough to get you off to a decent start in this. Please don't hesitate to let me know if you have any questions. Let me know through Ask My Instructor in my math lab, or you can just shoot me an email. Happy to help.